Okay, so we will learn about upcasting and downcasting in this lesson to using pointers. But before we do that, I just quickly want to do a quick review of the upcasting and downcasting using references. So you know that we have a class person, and then there is a class student that is deriving from class person. So person is the base class or our superclass, and student is the derived class or the subclass. So in main we could create a person reference, which and before that we need to create a person object, person, and person reference. I'll just call it person ref equals person. So actually that's just creating a reference to the same type of object. That's not really so interesting. We are used to that. But let's say if we have a student object and then we have a person reference, we can assign this to a student object. So this is upcasting. So upcasting is natural, where we are using an object of the derived class, and it's converted to a pointer or reference of a base class. So that's natural and doesn't need anything specific. And now of course, because this is because of the is a relationship, and you can say person ref.print. Now to downcast, what we need is we have a reference or an object, and we will see this is more natural with pointers. But if we have a student reference, and we will call it student ref, and we want to assign this to a person ref. Now we know that person ref is actually referring to a student object, but we have to downcast this to a student reference. So this is going from a pointer or reference of a base class to a pointer or reference to derived class. So this is not allowed without explicit typecasting, and we will use static cast for now. And we want this to be a student reference. We know that this is a student reference, so we compile this code, and I'm missing parenthesis, sorry. So we do need a parenthesis here, and then we can print the student ref dot print, and I'll compile this code and run this code so we can see this working. Usually when we print as a person ref, we only see this line which is printing only the person information, but when we have casted it as a student ref, it prints all the information. I will also show you here just so that we can know, we know that there is another constructor which takes 4 arguments: ID, name, GP, and major. So we can see that it's actually working here. So I'll choose 5 for ID, name as Christina, and then this is GPA 3.5, and major, let's say ECE. And now when I run this code, you can see this the person class 2 argument constructor is called student class 4R constructor. When we use it as a person reference, we see the ID is 5, name as Christina. And when we print this as a on line 13 as a student reference, where we have actually downcasted it successfully, which is because it's actually a student object, we can see this information major, GPA and major is preserved because that was actually a student object that was stored in a person reference. So this is downcasting. Okay, now of course I'm going to remove this code, and I'm going to actually use pointers now. So you know that we can create a person pointer star ptr, and I'm not going to show you a example where we actually create a dynamic object or we assign the address of a base class to a base class object. That's simple. But now in this case, what I'm going to do is I'm going to assign the address of the student object that we have created to the pointer of the base class. So person PTR, or actually I'll just give it a better name, person PTR. So person PTR is a pointer to a person object, and we are assigning the address. We have the only object we have is a student object, which is of a derived class, but we can have the pointer of a base class point to a object of derived class. So this is important, and this is upcasting. Again, we don't need anything explicit. That's very natural because of the is a relationship. A student is a person, so therefore a person pointer can point to a student object. And because when we do that, we can see, actually, if we have person PTR dot, we can see all the attributes that are available through the person object are available. Now we know that actually student object has many more attributes and methods, but we don't have access to them right now because person PTR is a person pointer, and so the only operations we can do are the operations that are, or we can call the methods that are related with the person class. So for example, person.print, if I run this, it only prints one line, which is person ID equals 5 and name equals Christina. So it doesn't call the print function of the student class, although the object is a student class. We can see we will see this in polymorphism and virtual functions later on. So this is upcasting, and the downcasting is similar. We will create a student pointer, which we will call a student pointer, and then I'm just breaking this into 2 lines so it's easier to read, although we could do it in 1 line. So now student pointer is, we know that person pointer is a pointer which is actually pointing to a student object, which is a derived class of person. So we are going to now convert the pointer of the base class to pointer of derived class, and for that we need explicit type conversion, and we will use a static cast again. The type that we want now is a student pointer, because we know that this is a student pointer, that on the left side of the assignment is a student pointer, so therefore we want the casting to be of student pointer, and what is on the right side is person PTR, which is actually the class of the base class pointer, and this is again downcasting. Now if I use excuse me, now if I use student pointer, we have access to all the attributes that belong to the student class, including the print function. When I run, you will see we will print all the attributes, including the student GPA and major, which is because now student pointer is a student pointer and the object is also a student. Now this could be dangerous sometimes, because what if the object that person pointer is pointing to is not a student object? Because that can happen, which we will see later on is possible. We could assign any other derived class of person to this pointer, and in that case the behavior is undefined, and so we have to be careful, and we will see some mechanisms where we can ensure that this is actually a student class object, which person pointer is pointing to. Okay, so that's all for this lesson. If you have any questions, feel free to ask as a comment or send me an email.